Let's start with the Module 4. The first chapter of the Module 4 is Data Link Control. We'll see the services of data link layer. There are three services of data link layer: framing, flow control and error control. We'll go with one by one. First we'll start with the framing. Before starting with the framing, we'll understand what you mean by frame. I think everyone can see this diagram. This diagram represents a frame. The packet is nothing but the message or original data or the payload which is received by network layer to the data link layer. Now data link layer will attach header and trailer to the packet to form the frame. Header consists the information regarding source address and destination address, whereas trailer contains the information regarding error detection and error correction redundancy bits. The process of forming a frame is nothing but framing. In framing, we have two types: fixed size framing and variable size framing. Fixed size framing, the size over the frame or the size of the frame is restricted or limited, whereas in variable size framing, size of the frame is not restricted, but to distinguish one frame from another frame, end of the frame and start of the frame, the flags are being included. It is done by two approaches: character or byte oriented approach and bit oriented approach. First we'll see the character or byte oriented approach. In this approach, frame is attached with a starting special bytes and with the ending special bytes. Those special bytes are nothing but the flag. You can just see the diagram. We have the packet, that is original data. For that, header, H stands for header, T stands for trailer. Header and trailers are attached. Now it forms the frame. For the frame, or at the starting of the frame, flag which is made up of special bytes is being attached. In the same manner, end of the frame is attached with flag. Now this whole thing we'll call it as character framing or byte framing. In the same manner, we have the bit oriented. In bit oriented, each frame is attached with starting bit pattern and ending bit pattern. You can consider this diagram. We have the packet original data, header is attached, trailer is attached, framing is done. For this frame, starting predefined bit pattern is attached. In the same manner, end of the frame is attached with predefined bit pattern. This bit pattern will be predefined and it is constant. But in both character byte oriented and bit oriented approach, there are some issues. Now we'll see those issues. First we'll move with the character oriented. So this part is character oriented. In character oriented, starting of the frame and end of the frame are included with the flag. If flag itself is a data or if flag is a part of the data, then how receiver can distinguish about the data flag and delimiter flag? As a solution, we have byte stuffing. The meaning of byte stuffing is nothing but include extra byte. That extra byte is a escape byte. You can consider this diagram. We have the original data. There are three different messages. In the first message, the first character is A, flag is the second character, third character is B. Now this whole thing is one data. Now the flag is the part of data itself. When sender want to send this data, sender will perform byte stuffing. Now we'll see what will happen at the byte stuffing. You can just consider after stuffing diagram of the first message. We have first character A, then the flag is prefixed with the escape byte. So this is nothing but byte stuffing. Then we have the character B. So receiver will receive the same form of frame. When receiver will receive this, at first time the receiver encounters the escape characters. Receiver will discard the escape character and treat the next character as the data. So at the end, receiver will send data A, flag and B to its upper layer called network layer. In the same manner, we have the second message where we have the character A, character escape and character B. Now, in this data, escape itself is the part of original data. In such a case, byte stuffing is done as character A. This escape is prefixed with another escape. Then we have the character B. So first time when the first escape character is encountered by the receiver will discard the escape character and consider next escape as the data. In the same manner, we have the third message. In the third message, escape and flag, both the characters are part of the original data. So the escape is prefixed with the escape. Similarly, the flag character is prefixed with the escape. Now, we'll see about the bit pattern. In the bit pattern, the predefined bit pattern we have as 0, 6 ones, then we have 0. If the same bit pattern is a data or it is a part of data, how receiver will distinguish between the bit pattern and the data? For that, we have the solution as bit stuffing. Meaning of bit stuffing is nothing but stuff a extra bit after 5 consecutive ones. That extra bit is 0. In character stuffing, the extra byte was escape and here the extra bit is 0. Now, just consider this example. We have the original data 0. Just you can have a count over number of ones. 1, 2, 3, 4, 5, 6, 7, 8. Totally we have 8 ones. Again we have 0. Again we have 8 ones, then 0. Now, when sender want to send this as a data, stuffing is done. We'll see how the stuffing is done. 0. After 5 consecutive ones, the 0 is stuffed. Again we have 3, 1, then 0. Again we have the consecutive ones. So after 5 consecutive ones, 0 has been included. Again after 5 consecutive ones, 0 has been appended. So whenever receiver encounters the 0 after 5 consecutive ones, then that 0 is discarded. Next stream of bits are considered as data. The same thing will explain by taking the example of sender and receiver. Now, first we will move with the character oriented. In the character oriented, the first character is blank, the second character is flag, third character blank, fourth character blank, fifth character escape, sixth character is blank. So this is the original data. We can call this original data as a packet or else we can call it as the payload. Now, to make a frame, we are going to attach header and tailor for this data. For this data, if header and trailer are attached, then it will make a frame. For the frame, to distinguish from one frame to another frame, we are going to add flags at start of the frame and end of the frame. This is the procedure. Now we'll see how the stuffing is done. Since the escape and flag are part of the data, stuffing need to be done. You can just see this diagram where the stuffing is done and frame is sent. Initially or the starting of the frame we have the flag, end of the frame we have the flag. To make the data as a frame, we are attaching header, we are attaching trailer. Then we have one first as a blank character, second character we have as a flag, but it should be stuffed or it should be prefixed with the escape. Then we have the flag, again we have the blank character, we have the blank character, then we have the escape. So before this or this escape is prefixed with another escape character, we have the blank. So this is the frame that is sent by the sender. Now same thing is received by the receiver. You can just see this escape and this escapes are nothing but byte stuffed escape. So here we have done two stuffing, but actual data the receiver will send from data link layer to network layer is again the original data itself. This is about character oriented approach. In the same manner we'll go with the bit oriented approach. Again we'll consider the original data. This is the original data 1 0, then we have 8 ones, again 1 0, sorry 1 0, 7 ones, then 0, we have 6 ones and 0. This is the original data. Again to make it as a frame, what we need to do, attach a header and attach a trailer. Then to distinguish one frame from another frame, in the bit oriented we are going to attach the frame with the starting bit pattern and end bit pattern. So this is nothing but bit oriented approach. Now we'll see the stuffing. In this stuffing is required because there are consecutive or 5 consecutive ones. This is the frame set. The starting is bit pattern or the frame with the starting bit pattern and frame with the ending bit pattern. Then we have header and trailer. This is the original data. We have zeros after 5 consecutive ones. The 0 is appended or included or stuffed. Then we have 110. In the same manner, after 5 consecutive ones, 10 is included. The remaining are 101. The same thing is received by the receiver, but actual data sent by data link layer of the receiver to network layer, it is nothing but the original one. So this is all about the framing. Now we will see the next service provided by data link layer. Next service provided by data link layer is nothing but flow control. First we will see the meaning of flow control. Flow control is nothing but there are some set of procedures where the procedures will limit amount of data at the sender side to be sent before waiting for the acknowledgement. Now we'll see why we need a flow control. Whenever sender sends a data at a higher rate than the receiver can process, in such a case we require the flow control. The flow control concept is explained by producer and consumer. If producer produces more data or the producer produces more faster than the receiver or consumer receives it, then the consumer may discard some of the data. In such a case, flow control is required. And one technique to control the flow is feedback based solution. You can just see the diagram, sender side data link layer and receiver side data link layer. So sender, what the sender will do? Sender will go on pushing the frames to the receiver. But if buffer at the receiver is full, then what the receiver will do? Receiver will not accept the frame or receiver will discard the frame. In such a case, there is loss of data or loss of frames. To overcome that, we have the technique called feedback. The meaning of feedback is whenever buffer of the receiver is full or whenever receiver is not able to accept the frames from the sender, receiver will send a feedback to the sender by saying or by asking the sender to slow down the transmission rate of the frames. So this is all about flow control. Now the last one we have is error control. The meaning of error control is nothing but both the error detection and error correction. There are mainly two methods to implement the error control. First we will see those two methods. One stands for method 1, 2 stands for method 2, and there are two concern. One is a frame corrupted and another one is not corrupted. In method 1, if frame is corrupted, then simply the frame is discarded. If frame is not corrupted, then it is delivered to network layer of the receiver. In second method, if frame is corrupted, simply discard the frame. But if frame is not corrupted, then acknowledgement is sent to the sender by telling the sender that receiver has received the frame. This is about error control. With this, we have completed the services of data link layer. Once we'll have the brief discussion. There are three services: framing, error control and flow control. Framing is nothing but attaching header and trailer to the original data called packet, and in the framing we have fixed size framing and variable size framing. In the variable size framing, two approaches: character or byte stuffing and bit oriented approach. In character or byte oriented approach, byte stuffing is done. In bit oriented approach, bit stuffing is done. Stuffed byte is nothing but the escape character, stuffed bit is nothing but the 0. Then we have the flow control. Whenever data transmission rate at the sender side is more than the receiver's processing rate, in such a case we require the flow control, and the technique used is feedback technique. So whenever buffer at the receiver is full, or whenever receiver is not able to receive the data from the sender, it will send a feedback to the sender by saying to, or by asking the sender to slow down the sending of frames. Then we have the error control. It includes both error detection and error correction. If the frames are corrupted, simply discard. If frame is not corrupted, in method 1, it is directly delivered to the network layer of the receiver. In method 2, the frame is received and the same message is sent to the sender in terms of acknowledgement.